travel, this section feels impossibly ahead of its time. It doesn't read like something written over 30 years before the invention of space travel. By speculating on what life might look like millions of years beyond his own time, Wells had inadvertently opened the door to the genre of speculative evolution.
People of Mars probably walk on their hind legs. Their barrel-chested bodies covered with pulling them down. Their ample skulls being crammed with intelligence. And their trunk-like noses indispensable for feats of engineering.
The next great frontier in speculative evolution emerged in the same year. Astronomer Percival Lowell produced an account of what he referred to as canals on the surface of Mars. What we now know to be an optical illusion caused by streaks of dust was at the time believed by scientists evidence that there was complex life on the next rock over Earth. Inspired by his findings, H.G. Wells would publish The War of the Worlds just 2 years after the time machine, a novel notable for popularizing the alien invasion story. Wells's tale about Martians invading Earth is widely interpreted as commentary on British imperialism. Yet War of the Worlds could also be considered another founding work of speculative evolution. Before the book's release, Wells published numerous articles speculating about what life on Mars might look like, discussing his theories for how plant and animal life might evolve. We now know that Mars can't support life for a range of reasons, but at the time, this was a risk. It's interesting to read these articles because they really feel like someone gushing about a speculative world they've created, and their early ideas for the Martians and the animals outlines are almost unchanged in War of the Worlds. It suggests this open project inspired the method to follow. One of the most important sci-fi novels the author talking about speculative systems. or external ears. And the most intelligent aliens of Darwin 4, the bizarre, floating Eosapiens, break the trend of aliens with human-like intelligence needing to appear humanoid. Following the success of Expedition, the book was adapted in 2005 into a CGI TV special for the Discovery Channel titled Alien Planet. Barlow served as the design consultant and one of the executive producers of the adaptation. Throughout the early 2000s, computer-generated television specials became a surprising haven for speculative works, including Charles Foley's Dragons of Fantasy Made Real, which explored the hypothetical evolution of a lost order of dragons. Joanna Adams's The Future is Wild also came out around this time, which explores future ecosystems in a nature documentary format. Dougal Dixon was actually one of the scientists who helped develop the project and assisted in designing many of the life forms. The Future is Wild is a speculative project that remains unparalleled in terms of scale and ambition, and there's never really been anything like it produced since. During the latter 2010s, speculative evolution had a significant, if often overlooked, impact on popular culture. Dixon's The New Dinosaurs heavily influenced the direction of Peter Jackson's King Kong. Even James Cameron's Avatar, which remains one of, if not the most successful film of all time, owes heavy inspiration to art Wayne Barlow created for the movie. At the same time that speculative evolution was influencing mainstream media, there was also an explosion of availability in online projects. And leading the charge for early internet speculative works was one C.M. Kozeman. Born in Turkey, the young artist and writer released the book All Tomorrows onto the internet in 2006. A fascinating and disturbing narrative exploring future human evolution, both through genetic engineering and natural means, the book is something to behold, at once both nihilistic and strangely hopeful. Taking inspiration from works like Last and First Men, All Tomorrows steadily grew an online following. Around the same time, Kozeman also released updates for a story called Sniad, a world-building project exploring the biology of aliens on a fictional exoplanet. Influenced by works like Barlow's Expedition, the sheer number of invented creatures and lineages makes Sniad one of the most biologically diverse fictional worlds. A few years later, Kozeman would release All Yesterdays with artist John Conaway and paleontologist Darren Naish, a book that speculated on how dinosaurs might have looked and behaved. This speculation actually helped inspire projects like Prehistoric Planet. The book also contained a section titled All Todays, which explored how aliens might reconstruct Earth animals based on the fossil record with no knowledge of their biology. Like species filling niches of a new environment, speculative evolution would become a bigger and more complicated genre than ever thanks to online possibilities. The early works of artist Alex Reese also hit the internet around this time, showcasing stunning depictions of alien life. In particular, Alex Reese would explore the development of an intelligent hexapod species called the Burin, creating one of the most fascinating and believable alien cultures across fiction. Leading up to the modern day, speculative evolution became more accessible than ever before, with a growing community of people inspired by the genre able to connect over vast distances. And today, speculative evolution is in the middle of a kind of renaissance. Creators like Christian Klein are now self-publishing entire speculative books like the Teeming Universe. Dylan Beta helped kickstart a new subgenre with Serena, which has popularized the idea of a seed world, a concept that involves leaving a few species on an empty planet and following their evolutionary path. Artist Roxy Valdez has continued the tradition of alternate timeline speculative evolution with their frog-centric Amphiterra project. The sheer number of speculative projects being developed online right now is amazing, and the future of this genre is looking bright. The history of speculative evolution is a long and interesting road. I couldn't cover everything, especially since exactly what can be defined as speculative evolution is somewhat nebulous, but I hope this offered a helpful overview of the major milestones. And speaking of milestones, this video is releasing on the week of my channel's 1-year anniversary. Whether you're a longtime fan or a first-time viewer, it means so much that you've stopped by and helped make this channel possible. I've explored many of the projects mentioned here in greater detail, and I have lots of exciting things planned for the future. And as always, thanks for watching. If you enjoyed this entry, please lend your support by liking, subscribing, and hitting the notification icon to stay up to date on all things curious. See you in the next video. On what planets are we most likely to find life? Our instinct might be to search for Earth-like worlds when shifting through the vastness of the cosmos. But what if that instinct is mistaken? Perhaps life, in its unrelenting stubbornness, can also be found in the churning atmosphere above gas giants, or the oven-like temperatures of a sun-scorched world. Such incredible forms of life are explored in Project C, a speculative biology epic by the incredible artist Charlotte Veldhusen, whom you can follow and support in the links below. The project is set within a vast congregation of stars known as the Cluster, where life has emerged upon numerous extreme worlds. So, for this entry into the archive, we can embark together on a journey across the cosmos and explore just some of the worlds that wait within the Cluster. Traveling into the Cluster, the first world on our voyage is a gas giant. From space, the swirling currents of the planet's outer atmosphere make it impossible to predict what lies below the clouds. Descending into the atmosphere, one of the strangest ecosystems in the Cluster comes into view. Life on Ondriel has evolved to steer through the cloudscape using gas-filled organs and chemical jet propulsion. Like fish within an aerial ocean, life on this planet has diversified into a vast array of unique niches. Furthest from our position, giant gargantua lilies float above the layers of the clouds, collecting sunlight with their castle-sized discs. These floating flora are so big they could be considered entire ecosystems of their own. And in the foreground, a hunter ambushes its prey. This curious organism possesses an exceptionally wide field of vision thanks to eyes that sit at the tip of long, maneuverable stalks. Like the stalks of snails, these eye stalks are retractable and can be pulled in towards the organism's body during hazardous situations. The aerial hunter's prey is surprised by the sudden attack, but this equally strange life form has a trick of their own, a spiked barb that poses a serious threat to the thin membrane of the predator's floating bell. Like any ecosystem, this sky is a stage for moves and counter-moves in the great game of life. The higher layers of Ondriel's atmosphere are rich in aeroalgae, an abundant food source that sustains a population of true giants. Various whale-sized cylindrical organisms spend their lives enjoying this bountiful feast, feeding by maneuvering their gaping mouth analogs through clouds of floating algae. From a biological perspective, these life forms are most comparable to the tube-shaped tunicates of Earth, sessile life forms that feed by filtering planktonic particles through their bodies. The filter feeders of Ondriel go a step further, however, by being both heterotrophs and autotrophs, meaning they are capable of both digestion and photosynthesis to reach their colossal sizes. Yet all environments have some form of apex predator. In the deeper parts of Ondriel's sky, the menacing Abyssocalid reigns supreme. One of the largest hunters anywhere in the cluster, this living dreadnought feeds on all manner of floating organisms in the stormy depths. At risk of lightning strikes, the Abyssocalid possesses organs that redirect electrical charge away from the vitals. But these organic lightning rods are not always effective. Sometimes, when lightning strikes in just the right spot, the volatile gases in the floating bell ignite, The resulting explosion spells the end for the individual. Yet ingeniously, such eruptions also send the creature's spores into the air currents, ensuring their lineage will live on. And like the deep sea, the most extreme life of all dwells in the dark sky many layers below Ondriel's surface. Here, the bristly, multi-pronged wind spears contend with more lightning than the abyssocalids, but the electrosynthetic wind spears have become one with the storm, having evolved to resist the immense burst of energy in a lightning strike, and can even use some of the deferred energy to grow and reproduce. Exactly when such a life form first emerged remains a mystery. Due to the gas giant's lack of a fossil record, it's tough to tell how the planet's evolutionary tree fits together, although its biodiversity suggests its roots reach deep into time. Ondriel is a fascinating and extreme world, but we must return to the stars once again and seek out other incredible biospheres. The next planet on our voyage lies within a trinary star system, meaning it has 3 suns. As a result, the planet, called Terminus, receives an extreme amount of UV radiation. A tidally locked world, one side of Terminus exists in perpetual day, and the other in perpetual night. Yet life endures nonetheless. Touching down near the sun pole of Terminus, we find a colony of tree-like organisms stretching up towards the sky. In this blistering region, the direct solar radiation eliminates anything but the hardiest life forms. Analysis suggests that these organisms are similar to Earth sponges. This makes sense, as experiments have shown that certain sea sponges can survive massive amounts of radiation, among the highest of any multicellular animal. Under the eternal summer, not much else can survive. To find more complex life, we'll have to journey further from the pole. Due to an abundance of suspended water in the atmosphere, permanent storms ravage much of Terminus's sunside. Yet on the rocky surface below the clouds, an unusual assembly clings to life. These are wind gaspers, creatures whose tough, clam-like shell helps keep them safe from the unforgiving weather. While they might appear simple, wind gaspers can survive many human lifetimes under the eternal overhead gaze of the red sun. On Earth, certain species of giant clams can live for a similar length of time, with many exceeding 100 years. Wind gaspers, forged by the planet's many extinction cycles, are resilient enough to withstand Terminus's harsh winds. Indeed, these clever lifeforms have even learned to use these winds to their advantage, feeding off the nutrient-rich material that the permastorm whips up. To survive on Terminus, one has to be resourceful. Within the equatorial zone of Terminus, one lifeform uses the winds for a different purpose. Thunder shadows are titanic hunters who soar above the equator in search of prey. Surprisingly lightweight, their sail-like wings catch the thermals of the storms, allowing them to cover vast distances each day. Small-shelled animals graze on the ground below, feeding on thick mats of bacteria clustered around volcanic hotspots. A flash of overhead lightning illuminates the circling thunder shadow. While passing through the equatorial zone, we'll be keeping one eye turned upwards. Yet not all of Terminus is so brutal. At some points of the season, certain regions of the tidally locked planet are downright picturesque, and a welcome reprieve from the wind and dust. Within Terminus's liquid oceans, a stunning array of biodiversity has emerged in response to the balmy weather and gentle currents. Here, segmented lifeforms splash near the surface of the shallows, pursuing tiny eel-like prey animals. While much of Terminus could be considered a dreary planet, scenes like this one reveal that even on an unpredictable world, incredible sights can emerge. It is tempting to stay longer, but it's time to continue our voyage. The next planet on our voyage is more temperate, and possesses a weaker gravitational pull compared to Earth. As we might imagine, the lesser gravity has a fascinating impact on the planet's native life. Stepping out onto the surface, we find a startling scene. With a great splash, A long-necked hunter pulls a squid-like organism from the water. This scaly specimen is a tannicroc, and they are a unique-looking creature indeed. A shoreline ambush predator, the tannicroc has converged on a niche similar to a crocodile's, just with an absurdly long neck. Planet Felora's lower gravity relative to Earth means that such a lanky body plan is quite effective. A precise plunge into the water can make short work of any unlucky prey. In crystal clear waters like these, nothing evades the tannicroc's reach. In the Feloran mangroves, the clear water becomes murkier, yet this dimness offers little anonymity for the species who swim amongst the roots. Above the water's surface, two keen-eyed predators are on patrol. In the foreground, a jeweled thorny kite carefully chooses a target. These rare specialists catch their prey by ambushing it from above, a strategy convergent with Earth's seabirds like gannets. In the background, the large-billed basket mouth scoops its beak full of plankton-filled water. Flamingos feed in a similar way, scooping up small organisms from the water and straining them through comb-like filaments. With these two specialists watching the murky depths, there's no place to hide. Out in deeper waters, prey animals have more room to maneuver, but have to compete with larger low-gravity predators, and a terror rules over the depths of the outer swamp. Like many lifeforms on Felora, at a glance, the titanic ichthyoserpens resemble an aquatic reptile, yet the ichthyoserpent's strangeness is betrayed by their insides. Like the cold-water hagfish of Earth, the ichthyoserpents possess multiple hearts to pump their blood. With 6 alternating hearts, 2 more than the hagfish, the ichthyoserpens has incredible stamina and can catch most anything that enters their shadowy domain. But not all of Felora is gloomy swampland. In a sunny region further inland, a stunning landscape has emerged. These tree analogs are called megacherries, named for the giant fruits that sprout from the top of their trunk. These fruits take full advantage of planet Felora's low gravity, possessing a lightweight and firm structure to help them reach gargantuan sizes. While these fruits once served an evolutionary purpose, their pollinator species has long gone extinct. As a result, despite the megacherry's ability to reproduce asexually, the species is slowly disappearing. Yet most species of trees on Felora are thriving. At the point where the low-gravity forests of Felora are the densest and the trees are the tallest, very little light reaches the forest floor. Here, various bottom dwellers feast on the detritus floating in from above. The native life in this forest of ghosts had become almost fully transparent, mirroring the denizens of the deep sea. It's a haunting sight, but even more fantastical organisms might be waiting on the next leg of our journey. At the edge of the cluster, we enter into the orbit of a lonely F-class star. Compared to our sun, this star is hotter, brighter, and considerably more massive. One wouldn't expect to find complex life on the sun-scorched planets in this system. Yet upon the dry surface of a world called White Rain, life has found a foothold nonetheless. Flocking near the rare sources of water, primitive crustacean-like creatures and bizarre sprawls of alien worms gather existence under the punishing white sunlight. Hollow, pipe-like organisms make up the base of this food web, feeding on algae and sprouts from the moisture. Mollusk-like organisms are waterbugs and epitomize some of the first land dwellers. Among the most active species are the swirling worms, hunters with a flexible, keratin-like exoskeleton that prey on smaller creatures. Although life on White Rain is relatively new, taken as a whole, this ecosystem is rich with early promise. On White Rain, shade is life. The desert sands of the planet bleach under the white summer sun. Despite adaptations against harsh UV radiation, not much survives the direct daylight. Many organisms choose to burrow in the rock and only come out at night. In other extreme regions,